Match the complexes given in column 1 with their characteristics which is given in the column 2. So if you observe the column 1, all the complexes have the D block element. That's a central metal is a 3D metal. So option T holds good for all A, B, C, D. Now you consider the rest of the options. A option, here the complex first one, nickel tetracarbonyl. This is a complex where nickel is having the configuration, nickel is in zero oxidation state, so the configuration will be 3D84s2, and 2 electrons are going to jump here during the hybridization as carbonyl is a strong ligand, and you are going to get sp3 hybridization. The shape would be tetrahedral, and EAN here. For central metal atom, the number of electrons would be 28 plus 8 electrons are given by carbonyl. Each carbonyl is going to donate a pair of electrons as it is monodentate, so you get 36. So option A has PQRST. That then the second complex, that's B, CO4 minus. If you consider this is option T is valid, and again it undergoes sp3 hybridization. That's also correct. The shape, if it is sp3 hybridized, then the shape would be tetrahedral. If you calculate EAN 27, there's a configuration, the number of electrons of the central metal, and 8 electrons are given by the ligands, and the plus 1, because here 1 electron is accepted, and EAN would be 36, but it is not a neutral complex. It's a anionic complex. As a result, you have the options P, Q, R, T, which are right. And the third complex which we have here is C. That's FeCO42 minus. And here it's not a neutral complex again, but the rest of the things are valid. So again, this holds PQRT are valid here, as here you are going to get for this EAN is equal to 26, that's the atomic number, plus 2, which is equal to 36, and it is again sp3 hybridized tetrahedral in shape, as the carbonyl is a strong ligand. So again PQRT are valid. The last one, if ECO5. In this particular case, if you observe, there are 5 ligands, 5 carbonyl ligands. As a result, you are going to get the configuration like this in D orbital. This is during the hybridization. 8 electrons, and these DsP3 would be the hybridization, and the shape will be trigonal bipyramidal. And so here P and Q are not valid, but again the EAN, if you calculate, that's 36. EAN is equal to 26 plus 5 ligands, each of them give 2 electrons, a pair of electrons, so plus 36 is equal to plus 10 is equal to 36. So here PQ are not valid, but RST, it's a neutral complex, so R is valid, sorry, S is valid, and EAN is 36, so R is valid, S is valid, and central metal atom is a 3D metal, so RST is valid. So the option would be PQRST, PQRT, again PQRT, and the last one would be RST. Option A is the correct choice.